Welcome back everybody. In this video, we are going to interacting with Sprite in our Flappy Bird column. Now that we have got our Flappy Bird and our background, we want to start to get the bird interacting with us. So Flappy Bird has got a very simple control mechanism. Essentially, all you need to do is tap the screen and then the Flappy Bird will start flying around. So how do we get a tap to be detected? It is very straightforward. We do it in render method and we look for if gdx.input, and then you can see there are a lot of possible options there. So you can even work with the accelerometer and other fancy bits. We want to look for just dots. So this will be called every time the screen is tapped. So for now, let's just log something saying that it has been tapped. When you are working with the GDX app, it is best to use the app login. So we use GDX app log and then something like thoughts. I'll give it for done thoughts me. So now we should find, of course, that we get a something as that the log every time we touch. So now we should find, of course, that we get a something as to the log every time we touch the screen. And what we actually want is for this bird to drop out of the sky. And then for when we tap the screen, for the bird to essentially be given a shove as if something hit it from underneath and it flies up and then continues, it falls. So essentially we want to create a gravity system which is actually surprisingly easy to create. So let's get the log showing and then I'll tap the screen. And there you go. You can see there it is definitely responding to that touch. Alright, so if we want to move the bird talking, let's set up gravity and then we'll set up our touch to interact with that. So for our gravity, we are going to need to know two things about this bird. We are going to need to know it is position and it is velocity or it is speed. So let's set that up. So we'll create those as floods bird y equal to 0, and then I'm going to call the position bird y. Now the x coordinate of the bird is always going to be the same. That's the horizontal coordinate. It is always going to be in the same center of the screen. It appears to be moving to the right, but it actually stays in the center of the screen all the time. So it is only the y or vertical position that will change, and I'll set that to 0 initially, but we don't want it to be 0 for long because we want it to be equal to where the bird starts. So that's going to be initially this position here. Now we could build this into the render method, but we only need to get the height once right at the beginning. So to make it more efficient, we'll do it in the create method, so it only happens once. So we want bird y to be set bird y equals gdx.graphics.getHeight divide by 2, subtract birds, I'll give 0, and get heights divide by 2, and then birds floppy state get height divide by 2, and both those birds have the same height. The only difference between them is one, they have got a wings up and then another got a wings down. So actually it doesn't matter which one we use. So just to make things a little clear, I'm going to use bird 0 rather than bird floppy state. Alright. So now this will work as it stands in the same way as it has already. So let's set up our velocity, which is going to be how fast the bird is moving. I'll make it for a float and velocity equal 0, and again I'll set that initially to be 0, and then what we'll do is we'll increase the velocity each time. So velocity, the render loop is called and then we'll increase or decrease the board y position of the board by the velocity. Board y minus equal to velocity. So this is going to increase the velocity each time the render loop is called, and it is going to decrease by the board y coordinate by the velocity. So we are going to get this effect of gravity that as it falls, it is going to fall faster and faster. Now one thing I'm going to do before we run that is, if this is how you run it, then board will likely drop off the bottom of the screen before you can do anything about it. So I'm going to create a variable that we'll need anyway. It is an integer called int GameState equals 0, and this will just keep track of the state of the game. So initially we are going to obviously just have the board hovering in the middle as it is just there until the user tap the screen, and then gravity will kick in. So far all of this we need to check if game state is not 0. So we are going to do all of the processing only if game state is not 0, and then when game is tossed, the screen is tossed, we are going to set game state equal 1. Now I'm actually going to just copy that, and we are going to have this in an else statement there, because we only need to do this particular check if the game state is 0. And most of the time, especially when there is lot going on, the game state is not going to be 0. So to save having to do the check every time, we'll put it inside else statement here. And of course, when you are making a game, you need to be fairly careful about system resources and do things as efficiently as possible. So we'll take reasonable step to make our game efficient even though our game is not particular resource heavy. Alright, so that will make game state equal to 1, which will then kick in with our velocity and our board movement. So it is only this velocity which is changing everything, then it will do the recalculate location depending on the velocity, etc. And we want the floppy state calculation to happen either way as well. So there will be a lot more code in this game state. It's not 0 part, because this is going to be where we put our game logic and our tubes and everything else, but for now it is pretty brief. So let's run the app. There you go. Now that was fine, but a little bit slower than I would have liked. So you can of course experiment with how you want this to work, but what I'm going to do is set another variable here called gravity. And because one seems to be a little bit slow, I'm going to initialize set it to be equal to 0, and let's make it a float because we are going to be using it to work with the floats. And you might well want to have a 1.5, 2.5 or any decimal point if you want to get it just right. So instead of increasing velocity by 1, we'll increase it by velocity equal velocity plus gravity. Alright, so we'll see how that works. Now the way we want our interaction to work is if the game state is not 0. So if we are playing the game, we want when the user tap the screen for the board to receive essentially a sweep upward, which is the same thing as given the board a certain velocity. Now I have played around with this, and I think a velocity minus 30 works quite well. Let's run it and take a look. So if we give the board a velocity of minus 30, because we are subtracting the velocity each time, that will subtract a negative number, so it will add to the board's height and board will shoot up. Now slightly alternation as well, I think it makes just a little bit more sense, even thought it will work in much the same way to adjust velocity. So let's give it a try now. So tap once, there you go. And you can see you can now tap and the board does not indicate head upward and then falls back down. So actually looking at that, and one more alternation before we are done with our game control is I found during development it is frustrating that the board disappear of the bottom of the screen, and so it is difficult to test things. So what I'm going to do to avoid that is look at board Y, and if board Y is greater than 0, so this will stop the board going off the bottom of the screen. It will stop also, however, our ability to shoot the board up. So let's have a quick, our velocity is less than 0, and then that will allow us to shoot the board up either when we are in playing mode. So we are in above the bottom of the screen, or if we give it a tap, so essentially it will allow us to move the board upward whenever we like. It will stop the board moving downward once it gets to the bottom of the screen, which just make our lives a lot easier. When we are doing testing, we don't have to get in there and keep the board at the top of the screen all the time. So here you go. Alright, I'm liking the way that move around now, and then let's see what happens. So the bottom of the screen, then the board stop, and we can still move the board upwards. So believe me, that will make our life a lot easier when we are testing. Alright, so now we have created our interaction with our board. Our next step is bring in our tubes and start creating several of them and get them moving from right to left, and we'll do that in the next video. I hope you enjoyed this video. Don't forget to like and subscribe my channel if you not yet. Let me know if you have any question, and I'll see you in the next video. Thank you for watching. Take care, peace, and happy coding.